Hello, math people. All right, this quick video lesson is going to go over the idea of what are like terms. What does that mean? And how to identify like terms within an expression. So let's get to it. First off, what are like terms? What is this idea? What do these words mean? So like terms in an expression can be one of two things. First off, let's just write ourselves out an expression like 3x plus 2 plus 4y minus 7. The pieces, the parts here, 3x, 2, 4y, and 7, those are all terms. And you can then go a little bit deeper and you can say, okay, of all of those terms, are any of them like terms? So here's how you can tell. Number one, like terms could be things in an expression that have the same, I call it the same last name. What I mean by the same last name is the terms have to have two things in common. The variable has to be the same, and if the variable has an exponent on it, that also has to match. So let me give you an example of like terms that fit this description. Uh, you might have like 3x and 2x. These two things would be considered like terms because their last name, so to speak, is the same. They both are in the x family, 3x and 2x. Um, what if we had 4y cubed and 10y cubed? These would be considered like terms. The reason being they have the same last name. They have the same variable, y, and both of those y's are to the third power, so those match. Now let me give you an example of things that seem like they should fit but don't. What if I had 3x, 2x, and then 5x squared? You want to say, oh, those all fit, but they don't. Although they all have x as their variable, one of the x's has the exponent of 2 on it, so it's not quite a like term in the x family. That one doesn't count here. Um, Another thing that sometimes throws people is if there's a term that's like 4xy, like, oh, it's got an x in it. It can go in the x family. Or it has a y in it. It can go in the y family. But no, this last name, so to speak, has two variables in it. This one only has one variable. It only has the x. So 4xy does not fit with 2x and 3x. And it wouldn't fit with something that just had a y on it either. This would have to look for other terms that have xy as the variable. So that's not a like term there. So number one, like terms, terms that have the same last name, aka they have to have the same variable, and that variable has to have the same exponent on it. The other thing that could make something like terms are constants. So constants, knowing your math vocab, constants are terms that are just numbers, no variables. In the thing I wrote up here at the top, 2, that's a constant. 7, that's a constant. So actually in this expression, 2 and 7 are in the same family, so to speak. They don't have a last name, but they are considered like terms. So anytime you've got numbers all on their own with no variables, those can be grouped together as like terms. And quickly, let's look at a couple expressions. All we are going to do is identify the like terms in each of these expressions. So in this first expression, I noticed that there's 5n and 3n. Those both have the same last name, n, and those would be considered like terms together. I also notice I've got 4m and 2m squared. Nah, just kidding. Those are not like terms. Those guys don't get grouped together because they both have an m, but this one's got an exponent of 2. This one doesn't have an exponent. So they're kind of similar, but they would not be considered like terms. So actually, this first expression only has one pair of like terms, and that would be 5n and 3n, nothing else. So there's our first one. In this example, I think there's more than one pair of like terms. I'm looking at this and I see 2x 3x, those are like terms. Those guys go together. They're both in the x family. And something else I see is 3x squared and 2x squared. They both have the same variable and exponent combination, so their last name, so to speak, matches. So we got two pairs of like terms in this expression. 5y hanging out here, no like terms go with that. It's all by itself. He's a loner. I think I have one more example we'll take a look at, and that is this big old expression. Now, I see 5c and c, also known as 1c. Remember, if there's a variable on its own, the number in front of it, the coefficient, is just a 1. So 5c and 1c, those are both in the same family. They both have the same last name, c. Those would be considered like terms. We also have 3.2d and 1.1d. Those are considered like terms. They both have d as the last name. I don't see any other like terms, but there's some interesting ones just to look at here. You've got 4cd, kind of close to c, but not quite, because it's c and d together. And it's kind of close to d, but also does not fit in either of those families. So that's a term all on its own. Same with d squared here. It's close to the d's that we've circled, but it's d to the second power, whereas these two terms are just d to the first power. There's no exponent on there. So that's how you identify like terms. And then there's another lesson to follow this, which shows us how to combine like terms. So check that out next. But make sure that you're able to identify like terms as a first step. It's an important first step before you can simplify expressions by combining like terms. If you have questions, let me know. Otherwise, happy mathing. Ta-ta for now.